Hello and welcome to another WJEC A-Level Physics question. This time it's question 4 from June 2016's PH4 paper, and it's about specific heat capacity, which nowadays is in Unit 3. In the question, you've got a metal saucepan of mass 0.9 kilograms. It's got 1.6 kilograms of water in it at a temperature of 92 degrees Celsius. And the water and the saucepan are in thermal equilibrium, and the system is isolated from its surroundings. We're going to explain what's meant by thermal equilibrium. Well, if two objects are in thermal equilibrium, there's no heat flow between them. And the reason for that is that they are at the same temperature. So generally in physics, heat energy will flow from hotter objects to colder objects. So if there's no heat flow, those two objects must be at the same temperature. Next, vegetables of mass 1.1 kilograms and temperature 17 degrees Celsius are placed in the water, and the system's left to reach thermal equilibrium once again. We're going to describe in terms of heat flows how thermal equilibrium is reached between the saucepan, water and the vegetables, and calculations are not required. One quick point is because the system is isolated from its surroundings, we're going to ignore any heat losses to the surroundings. So basically what's going to happen here is that the vegetables are going to gain heat energy, and the amount of heat energy that they're going to gain is going to be equal to the amount of heat energy lost by the water and the saucepan. So let's put that down along the lines of this. So heat energy will flow from the water and saucepan into the vegetables. And that will keep on going until all objects, the water, the saucepan, the vegetables, are at the same temperature. Slightly more involved explanation could talk about, first of all, heat energy flowing from the water to the vegetables, because the vegetables are in contact with the water, and heat energy flowing from the saucepan into the water because they are in contact, and so on until eventually everything's at the same temperature there. But the gist of it is that the heat energy lost by the water in the saucepan will be equal to the heat energy gained by the vegetables. And we're going to use that with this data in the next question to calculate the final temperature in the mixture. So what I'm going to do is I'm going to write an expression for the heat lost by the water. There was 1.6 kilograms of specific heat capacity, 4,200 joules per kilogram per Kelvin, and it's going to drop from 92 degrees to a final temperature of theta. Now it's important when doing these method of mixtures questions to put the temperature change in such a way that it will give a positive number. So here theta is going to be less than 92, and therefore 92 minus theta is positive. We've also got the energy lost by the saucepan. The saucepan was 0.9 kilograms, 500 for the heat capacity, specific heat capacity, and the same change of temperature. And that will be equal to the energy gained by the vegetables, 1.1 kilograms of specific heat capacity, 3,500. And this time we're going to write the temperature change as theta minus 17. Because the temperature at the end, theta is going to be bigger than 17, and we need this bracket to be a positive number. We can factorize 92 minus theta on both sides and add the terms of 1.6 times 4,200 to 0.9 times 500, and we will then get 7170 times 92 minus theta equals 3,850 times theta minus 17. If we expand out the brackets, 659,640 minus 7170 theta will give 3850 theta, minus 65450. I'm going to use all the figures here as I'm working through to avoid any rounding. Next, we're going to gather like terms on the same side, so we're going to gather all the numbers on the left and all the terms with letters in on the right. So we're going to have 659640 plus 65450 equals 3850 theta plus 7170 theta. The left hand side will give us 725090 and the right hand side 11020 theta. So finally theta will be 725090 divided by 11020, and that gives us theta to be 65.8 degrees Celsius. So just be careful, try to avoid rounding, don't be afraid to write out each step. Finally, we've got to explain what will happen to the final temperature if the system is not completely isolated from the surroundings. Well, the idea here is that some heat energy will be lost to the surroundings. So the final temperature will be lower. If you like, less heat energy has gone into the vegetables, so therefore they can't be as quite a higher temperature as we were expecting. So thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.